this last video, I just couldn't continue on from the last video because it is kind of its own little thing. So what we're going to be doing here is proving that what we got for the equation of the inverse is actually the inverse of our original function. So I'm going to take these equations for these graphs that we just did. So we've got y equals 5x plus 8, and we've got y equals x minus 8 over 5, right? So we've got our original function and our inverse function. Do and do. What we're going to be showing is that these equations are inverses of each other, and we're going to do that via composition. And the only reason I kind of love this is that it gives you a use of something that you learned in chapter 2. Okay, so what it is that if I plug in a value like x is 1 into my original equation, then I get y is 13. If I then take that y is 13 and I plug it in for x in the inverse function, I get back to 1. So in other words, whatever my input was here is my output of my inverse function. And that's what this is going to show. So what we're going to do is we are going to be taking composition of functions. So you're going to take the inverse function of f of x, and it should simplify to your input, x. And then same thing here, you're going to have your function, and you're going to find your function at f at your inverse function, and it should simplify to x. It's kind of a weird process, but it's kind of fun. So what it is that the first thing we're going to do, let's do first off f of inverse f of x. Okay, which means we're going to be taking our inverse equation and plugging it into our original function equation. Okay, so what that's going to look like is you're going to take this and you're going to plug it in for x in the original equation. Okay, so we are going to be taking the x minus 8 over 5 and plugging it in for x in the original function. So the original function is 5 times x plus 8. And in for x, we are going to put x minus 8 over 5. That's the first part. The second part is that we're now going to simplify this. So 5 divided by 5 is 1. So I'm left with x minus 8 plus 8, which gives me x. Yay! And now I have to do the other side of it. So I'm going to find the inverse of f of x. So in other words, into my inverse equation, I'm going to plug in the f of x equation. So this time, the f of x equation is 5x plus 8, and I'm going to take that and I'm going to plug it in for x in the inverse equation. So now I'm going to take 5x plus 8 and I'm going to plug it in for x in the inverse equation. So that's going to look like, whoops, there's the x. I'm going to put in 5x plus 8, and then I've got minus 8 over 5. Okay, that's the composition part. Now I'm going to simplify. On the numerator, I've got 5x plus 8 minus 8, which is just 5x over 5. And then 5 divided by 5 is 1, and I got just x. So since they both simplified to x, that means that I did it right. I used composition of functions to show that the inverse function of f is as given. All right, have fun.